In today's chemistry riddle, we have a rather complicated looking starting material because of all those stereogenic centers. And this molecule will be treated with MCPBA in the first step, and in the second step with LDA, a sterically hindered base. Well, we should pay attention to the stereoselectivity of the process anticipated. MCPBA, oxidating agent. It will transfer an oxygen. In the preceding video, we have seen that as a reagent for a Baeyer-Villiger oxidation. Well, for Baeyer-Villiger oxidation, you need a ketone or an aldehyde. Here we have a carbonyl group, but this is a carboxylic acid amide. This has already a high oxidation state. If we oxidize that, we will have a carbon dioxide derivative. Or it doesn't work with MCPBA to oxidize that. On the other hand, we have an olefin, high electron density. Well, MCPBA is known for transferring an oxygen in the formation of an epoxide. So, in the first step, it is rather clear that we will get an epoxide here. Three-membered ring with an oxygen. The other stereogenic centers are not affected at all. And what about the stereoselectivity of this process? So, this bicyclic molecule has a roof-like structure. So, the oxygen that is transferred from the MCPBA will attack not from under the roof, but from above the roof, and therefore the oxygen will sit on the roof and not underneath the roof. Next step then is LDA, the sterically hindered base. Where do we have an acidic, especially acidic hydrogen at all? Well, here, alpha to the carbonyl group. This one also sitting on the roof, above the roof. So here we will deprotonate and generate an enolate system, nucleophilic center here. Where do we have electrophilic centers? Oh, the newly formed epoxide. This is electrophilic, this is electrophilic. That carbon is more close to this one. This is the nucleophile intramolecularly reacting here, forming a three-membered ring, three-membered carbocycle, and at the same time opening up that three-membered heterocycle, the epoxide. So, what will be the result? Here the nitrogen, hydrogen, carbonyl group. This is the newly formed bond. Here the CH3 group, and here at this position the oxygen will sit, and with a lithium from LDA. Well, this is the anticipated stereoselectivity. Here the CH3 group was behind the whiteboard. Here it will be in front of the whiteboard, no problem, since an epimerization can take place here. As soon it is deprotonated, we change from sp3 to sp2. That means this is a planar system then. And afterwards, after bond formation here, it's sp3 hybridized again. Thanks for listening.